welcome back, everyone. I hope you had a nice, relaxing break. First up, after our break, we have here Garth Kidd to tell us what our Python was up to at 3 a.m. I'm looking forward to finding out the answer to that. So Garth straps open source libraries to each other for a living, lives in Newcastle, and occasionally dabbles with microcontrollers. His Halloween plan for the last 4 years has been to wire a microcontroller to a cardboard cutout of a Dalek and have it yell "exterminate" at passing children. You sound like a lot of fun to have as a neighbor. That was not sarcasm. I mean it. All right. Garth will be taking questions at the end of this time. So please, if you have any questions for Garth, pop them in the questions tab above the chat in Venulus, and I will be passing your questions along to Garth at the end. All right. Thank you, Garth. Over to you.
No worries. Thank you. G'day, everybody. I'm here to talk about observability with OpenTelemetry in Python. And this is the bit at the beginning that doesn't have its own span. At the end, there'll be time for questions and the tabs somewhere up there. I'm Garth. I'm speaking to you from a Awabakal country. I've got some minor Python claims to fame. I had a popular question on Stack Overflow once and nearly got sued by Apple. But I'm your guide today because I've been practicing with observability for, 4 years now with Honeycomb, with OpenCensus, and now with OpenCensus's replacement, OpenTelemetry. But what's OpenTelemetry? OpenTelemetry is an observability framework for cloud-native software. They break it down on their website. But you don't have to read this slide. You can read the next one. OpenTelemetry is software to help you understand your software's performance and behavior. I'll break it down a little more. It's a collection of other people's code in the form of tools, APIs, and SDKs to help you instrument your code to generate, collect, and export telemetry data, including traces, metrics, and logs. And then switching to my words, regardless of which language, framework, library, service, database, cloud vendor, anything that you're dealing with. Their goal is to ship everything except the query platform. It is super ambitious. Before I get to the code though, better nail down some terms. What even are logs, metrics, and traces? Because before I tell you how to do OpenTelemetry tracing in Python and how to get best results, I should nail down what we mean, because while we've got a long history with logs and metrics for decades, traces not so long, albeit that this is with a very Unix bias and the mainframe guys are probably a bit cross right now. All of this is it's long enough for us to feel certain about what we mean when we say logs, metrics, or traces. But it's not necessarily long enough that whoever we're talking to agrees on all the points. I mean, there's wide consensus that there are 3 of them, thanks largely to a Peter Borgen post about, this was in 2017, massively influential, widely credited with kicking off the idea that there are 3 pillars of observability. Everyone got the idea that any one of these systems could do all 3 of the jobs if they just tried hard enough. I think Gartner baked that into their definition of the APM segment. If you want to get in that upper right-hand corner, you got to do the lot. But I fundamentally disagree here. Each one of these loves one piece of your operational data and kind of tolerates the others, at best. Logging systems, for example, love your messages. Everything else is optional. For example, you might send RFC 5424 syslog packets at your new logging vendor, only to discover that they ignore the timestamp. And then when they fix the timestamp, they're still not paying any attention to the protocol's structured data elements. I guarantee you, though, a logging vendor will always keep your message. Metrics, on the other hand, love your measurements. They might tolerate metadata that you send in a metric, but maybe they insist on it being a number. They might let you add key value pairs in the form of tags or labels and then warn you not to. And time itself is fuzzy in metrics land. I mean, they know when they scraped it, but it's not necessarily part of the data. Meanwhile, tracing systems love your span context. And this is super. Microservices scattered our logs, right? Traces help us join them back together. And they add this extra timestamp that tells us for sure whether the number we're looking at is when it started or when it ended. Each system has its own piece of the puzzle. It might seem academic, but we are now responsible for solving the puzzle. Welcome to the second wave of DevOps developers. It's our turn. Data, though, it's broken up. The details of any one request are spread across logging, metrics, and tracing systems, and spread out within each of them. We can't keep our eye in any one place. Finding problems with dashboards is a bit like finding fire hydrants to prove you're human. And some of this we've done to ourselves. This example here uses string interpolation, thus destroying any effort the Logger subsystem might be doing to give a structured output. And it's spreading the data out across 3 messages when it could have used just one. But some of the problem is forced on us. Metrics, for example, they have to be separate. And you've kind of got the idea that you might be able to use these key value pairs to tie them back together. But the vendors warn you, like Prometheus tells you, please keep the cardinality, that's the number of unique values associated with any one key, to less than 10. And then put those key value pairs only on a few metrics. They say the vast majority of your metrics should have no labels. And this means that we just can't, pick at random that we're going to break down our 400s by customer ID to see who's affected. We have to look elsewhere. So what OpenTelemetry does for us is they bring it all together. We get the timestamps, span, name, kind, and context from tracing. We get the key value pairs, the measurements from metric systems, the metadata from our structured logging, and it's all in one spot. And then, better yet, they couple it with these strong conventions for what they expect to see. They, just for the attributes alone, there are these other things called resources, I'll get to them. They define a few dozen top-level groups in 2 categories, the attributes and the resources. And they define which ones they expect to see, which ones they expect to see together, and what the values look like. The attributes differ request by request. The resources stay the same for any one process and help you break things down like by which host, which log, which Lambda execution engine, that kind of thing. And so if you look at just the attribute conventions, the ones that change from request to request, you've got the HTTP ones, the method, the route, the status code, network ones, which tell you which IP address was talking to you from which port to which port, database ones, name, operation, statement, super useful. And then some others, including vitally the end user ID and the service identity, which helps start you tying all of this back to your business. The code namespace I've found is less helpful than you'd think. Anyway, the spec insists that these all get put together, so you can rely on being able to break down your data by any of these and then filter by any of the others and break down by one of the others again. And you get all of these for free from new code that somebody else wrote, so no one's leaving it out because they're in a hurry or for backwards compatibility reasons. You can rely on it all being there. And this gives you that happy spot in the middle of Peter Borgen's diagram. The happy combination of what we could get from the data that we'd been previously putting in tracing, logging, and metrics. We finally got our request-scoped aggregatable events that he talked about. And that is what you get from OpenTelemetry tracing. Excuse me. So, now we know what we're talking about, OpenTelemetry tracing. Let's talk about how to do it in Python. So like I was saying, it's an observability framework for cloud-native software, collection of other people's code to help us with ours. For this talk, I'm going to be concentrating on the API surface that you're going to be dealing with, on how you instrument your code to generate this data. It'll get exported automatically. And I'm going to be concentrating on traces. Python is stable for tracing alpha for metrics and not implement it at all for logging. And for the examples, I'm going to be concentrating on Flask, and I think there's one usage of requests. So first, let's add our packages. The API is the bit you talk to. If you maintain an open source package and you really get enthusiastic about this, you can take a dependency on that and start calling it from inside your package so that it's like pre-integrated with OpenTelemetry. And that'll save everybody else the effort of monkey patching your software later. It comes with a no operation back end that does literally nothing for anyone that hasn't done the work to hook the rest up. So you can call it safe in the knowledge that nothing bad will happen for anyone who's not joining in. The SDK does the heavy lifting. The exporter sends it to somebody else. And then we've got these two instrumentation packages for Flask and requests, neither of which have a dependency on the API itself. Here's a simple Python example. I'm going to dig in a little on PEP343 context managers. That's the thing behind the with statement. The with statement calls somebody and it gets an object, and then it calls into the object to do work at the beginning using a dunder method, thanks Joachim, called enter. It gives you a variable to use during and then tidies up at the end of a block of code by calling exit. And this really suits our pattern here where we're constantly creating a span, setting attributes, and then setting the status when we're done, though that's optional, defaults to OK. Most of the code, though, is not going to be created by you. It's going to be created by an integration written by somebody else. And there are 33 of those today. Let's look at Flasks. Now, this is a simple Flask example. It has no tracing in it at all. It's the usual hello world. And a bit of a disclaimer here. I'm a Flask beginner. I had no idea how the app worked until Vibhu's talk just now. Let's add tracing. So I've cheated and shoved most of it into a different file, but the point I really want to make here is that you can get good results without touching every function you wrote. You just hook up the automatic instrumentation at the beginning and you're going to get okay results. The hookup code, though, looks like this. Don't panic. It's just a whole bunch of boilerplate. Import some modules, create a few objects, hook them together, and then the fun bit with the orange arrow, run the monkey patching code. It uses this package called wrapped under the hood to help it reach into Flask and do all the work that it didn't. And then if you uninstrument it, it just quietly pulls all the code back out. It's scary. Anyway, or you can use if that's too much work, you can use a vendor distribution. This one's from Lightstep, but don't panic. I'm pretty sure that all of the vendors will end up shipping one for you. Either way, once you've hooked up all of the automatic instrumentation, you've got free attributes. I'm sorry, I got lost. So having got all of these semantic attributes together for very little effort, let's add our business concerns. This is awful code. Call out to Simon for the AST talk. I don't know whether using the AST library to parse a request query variable is a great idea, but let's have some fun. One point I want to make here is that you're not seeing any code to start a span. That got done for us, and I wouldn't go to any extra effort to do so. All we've got to do is the line pointed to by the orange arrow there, get current span, and add an attribute that relates what's going on in this method back to our business. That's all you got to do. And what we get for that is that mixture of all of the automatic stuff with our stuff in that one data structure. Now we can relate our business concerns to all the rest. If something goes wrong though, let's say something crashes out. The only special handling here is for Flask, so that we get a status 400 instead of a 500 when someone gives us malformed input. The OpenTelemetry handling of exceptions is automatic. And what you get is an extra part of the data structure, the status, reflecting that there was an error, and you get an event in the events thing to give you all of the detail you could want there. And most importantly for my money, it keeps everything else intact, so you can still relate what happened to the context in which it happened and what other measurements, metadata, etc. Resources. Since you got exceptions for free, of course, let's add some counters. We've got spare time. I'm going to use another context manager. We're using with again. This time, the context manager is maintaining a counter that we can increment. So with, like I was saying, does work at the beginning, gives you a valuable to use during, and tidies up at the end. And so we create one in the orange line, and then we use it in that pages out plus equals one thing there. Easy. Now, if it's too much magic for you, just use try finally and set attribute. You'll be right. The implementation of the context manager looks like this, and it's not far from the hello world for context managers. The dunder methods are all here. There's your enter, which is the work at the beginning and providing the variable. There's your exit, which does all of the work at the end. We return false to let it know that we're not trapping the exception. Oh, and one thing I should call out here is the OpenTelemetry teams are very careful to ever avoid crashing. So you might feel like you need to defensively wrap this in another try finally, but you can probably get away without it. Anyway, and then the add is the other dunder method, which lets you do the incrementing. Heap of fun. A context manager to add measurements looks like this, and this is using a different style of context manager where it wraps a generator, takes the first result from it, and it treats that first block of code as the enter. It treats what you yielded as the context variable, and then it re-enters the generator and treats anything that happens after the yield as your exit. It's a heap of fun, but like I say, this is boilerplate. You just get to call it later, and there'll be some code which shows off how. Once you've added your measurements, consider adding baggage. Now, baggage is a sort of goes alongside your spans, propagating by itself. And it's another collection of key value pairs that gets sent to other services in the request headers, like you can see at the bottom of the slide there. It's got to be copied to the span attributes by you. It does not happen automatically. So it's a little bit of extra work, but it's super valuable because otherwise you'll hit one of these database spans, but the database span does not have the end user.id that you need to track down the user who's doing the thing, right? So the code for baggages looks like this, and the API, it's a bit awkward to me, but that's okay. Context managers again to the rescue. We can define one, and then with the baggage context of end user ID, we can go off and do stuff with our span, and that all works. Now, I bet you could use Christopher's talk to write a function decorator to do this. I also bet you could write Flask middleware to do this, but I'm a beginner here and I couldn't pull either of those two things off. Or, again, you can write it using try finally and do it all yourself manually so you can see what the code's doing. It's your call. But that's all you need. Most of the work is in boilerplate and helper methods, and then you just sprinkle a few extra bits of code across your request handlers to help you tie your metadata and your measurements into the data that's being output. Here you can see the duration attribute. Oh, I'm sorry. I forgot to modify the code on that one. Don't worry. With duration attribute, you can do your measurements that way. You get all the data you need, and you can just enjoy the results. Right. So that's how we do our OpenTelemetry and tracing, but I should give you some overall advice for how to get best results on your journey from nothing to observability. If it's a greenfield opportunity, I do urge you to install metrics and logging first. You can derive metrics and logs from request scoped events, but nobody cares. They're used to these tools and they will stick to what's familiar to them in an emergency. So will you. Please hook them up. Then instrument your inbound and your outbound requests. You've got 33 automatic integrations available to you. And if you have to write any, please contribute them back. It's all in one repo called OpenTelemetry Python Contrib. Add resources to make sure that you can break down by release, branch, commit, hash, source name, whatever else is relevant. And then quick as a flash, like cash in your easy wins. send it somewhere. Ideally, you send it to some dynamic dashboard product like Honeycomb or Lightstep. All of my experiences with Honeycomb. They would both argue that you need a column store for this kind of data so that you can query it really fast without the need for any indexing that would be basically given the dimensionality we're talking about here, a right amplification attack that you would then have to pay for. And they both have very generous free tiers. Your usual log and APM vendors will assure you that they're fine taking this data off your hands, but do check the dimensionality and the cardinality impact. You don't want to tag by user ID and then have it cost you $4,500 a month. Honeycomb's dimensionality limit for the record is, I think, 2,000. And you can send up to 100 kilobytes of data with any one event. They really do advise you to just keep stuffing those attributes in. Having sent it in, start looking at it. Every time you ship, you need to be familiar on it to rely on it in an emergency. And by this point in our journey, we've already got some easy wins. Let's keep going though. Loop back and start adding attributes to your upper spans. You want to double check that you're getting the semantic attributes. You want to make sure that you're attaching all of the semantic resources. Contribute those fixes upstream if you need to. And then add your measurements and most importantly, your metadata. You want your end user ID, you want an account ID, you want a project ID. Anything else that is relevant to your business needs to be in there so you can break down by it later. Once you finish that, add more attributes. These are from Honeycomb's demo of the Ruby Gems dataset. If you watched the presentation on PyPy earlier and you want to see how the other communities live, you can climb into Honeycomb's demo of this dataset and start slicing and dicing, pulling data up. It's a heap of fun. But if you're adding everything that's relevant to you, you will have more than this. Seriously, add even more attributes to your spans. This was from one of my services. It was an image conversion library package that I put in an Amazon Lambda function. And now this was with Open Census. Release information would be in resources, except for the age in days, which would have to be dynamic. That'd be in an attribute. But you can see I'm counting all of the input images, all of the output images, how long it took, and this is still not enough. That said, it is 50 columns. It's not really feeling so loggy anymore, is it? But don't worry, don't panic. Your existing skills will get you here. And then, like I was saying earlier, you probably want to propagate baggage. The trace context is free, tying all of these interior spans to your outer span. But if you want those interior spans to have your business metadata, the end user ID, the account ID, or the project ID, then baggage is definitely worth the investment of the extra code you have to write for it. You might literally not find the trace to look at without the baggage, querying just the events you're getting from those database queries, say. Excuse me. And then I guess finally, for the stern warnings based on bitter experience, don't lean too hard on tracing. Like, don't try to fill in gaps in your trace waterfalls. Don't wrap every function call in a span. Don't write separate spans for your controller layer and then another bunch of separate spans for your model layer. In short, don't trace like you log. Otherwise, you'll end up staring at it like your logs. It's just not that effective. Instead, summarize what's going on inside all of these and put them on the attributes of the outermost span as measurements. So, when you see that suspicious bit at the beginning and the suspicious bit at the end with no span, don't panic. We know some of it's authentication, some of it's decoding, some of it's encoding and sending. That's what measurements are for. And then finally, for those of you who are worried about the fire hose of information that's going off to our destination here, don't panic. You can sample it if it gets overwhelmed. Because all of the data is together in one data structure, it's representative. Like, all of those things genuinely did happen together. And so if you take that one event and then throw away the next 9, that's okay. Or if it's from your load balancers health checks, you can throw away 99 and 100. There's, however you do it, you end up with operationally useful data still coming out. And the vendors at the other end of this data compensate for that with the numbers that they're displaying to you. So you can just like crank up and down the volume according to basically the bill at the other end, and you'll still be able to enjoy the results. You can do the sampling at two different places. One is in process. The OpenTelemetry API, or rather the SDK, has this interior processing pipeline, which you configured in that boilerplate at the beginning, and you can configure sampling there, either explicitly in your code or just by setting a couple of environment variables. You can also do it out of process. You might be deploying the OpenTelemetry data collector, either the raw one shipped by the project or a distro from your cloud vendor or APM vendor. And it can be also configured to do this kind of sampling. Remember, surviving events are completely intact and you can make perfectly useful decisions based on this. Most importantly, though, look at it every time you ship. You might find something. Anyway, we're done. This is the bit at the end with no span. I've talked to you about logs, metrics, and tracing, about how to do OpenTelemetry style tracing in Python, and given you a little bit of advice on how to get best results. I hope all of this helps you know what your Python was up to at 3 o'clock in the morning. Thanks very much. I've been Garth.
I was on mute. It was bound to happen. Thank you so much for that, Garth. You've certainly opened a whole new world for me. I'll have to have a serious think about that. Okay, so we have a question, but we have 3 minutes, so there's time for a few questions. If you are watching this, please go put questions in the question tab now. All right.
Thank you, brave questioner.
Yes, it's always very brave of the person who starts us off. All right, our first question is, if you already have metrics, in what scenarios would you want to set counter or duration attributes in your span, if they understood the use case correctly?
Yeah, good question. I think mainly if you've got metrics and you're already getting all the answers you ever need from it, well, first you can just stop there. That's fine. If you find yourself ever baffled by the relationship between what's happening on one graph and what's happening on another graph, though, and you can't relate those to each other, then that's exactly the time that you would want to go and look at the OpenTelemetry tracing data to see if you can figure out what's going on. Especially if, like I was saying, you've left a lot of the pertinent detail that would help you tie those things together out of the label or tags that you're putting on your tracing for budget reasons. I think the number that is most going to drive you over to your OpenTelemetry data is latency. Those duration MS columns are just super. But I mean, I've also found like the logarithm of the number of seconds since launch is a wonderful thing to, I mean, I'm sure you could put that on your metrics as well, but if you whack that on a graph and then break down everything else, you can very quickly correlate problems against when something rebooted or relaunched. I hope I answered the question.
You definitely answered the question that I was going to ask, which was like, at what point would you want to move on to trying this? Yeah.
When you're sick of flipping through dashboards or glazing your way through logs, yeah.
Yeah, I think we've all been there. All right, so there's quickly. Can you quickly recap what a span is versus what a baggage is?
Oh, right. So spans are the data structures that we end up sending to the machinery that we're querying with. And then you've got a span context, which is basically an index into that. It's got your trace ID, the parent span ID, and the span ID. We send The span context and baggage as headers to let somebody else know how to join in on an existing span. But the baggage itself is like this separate key value store. You could shove anything you want in there and ignore it if you wanted to in everywhere that you sent it. Whereas anything you put in the span is definitely going to get sent to the machinery at the end unless some machinery somewhere in the middle strips it out. That aside, yeah, I might head to the discussion room. I'll probably go for the room number 2 and try and unpack it more later. I haven't thought through an answer to that one. I'm sorry.
We're putting you right on the spot with all these questions. Yeah. Okay, we're out of time, but there is one more question there. So would you prefer me to send people over to the video hallway chat or the text chat?
Yeah, I'll go to hallway chat number 2.
Okay, video hallway chat number 2. I will go and drop the last question that we didn't have time for in the text chat over there in a few minutes. And another one's just popped up. Great. All right. Brilliant. So head all over to the video hallway chat room number 2 to chat with Garth after this talk. Okay, we're just going to have a short break. Oh, thank you again, Garth. That was great.
Thanks.
We're just going to have a short break, and then our next talk will begin in 14 minutes. We'll see you all then.